On April 20th, 2010, the Deepwater Horizon exploratory drilling ship 50 miles offshore in the Gulf of Mexico exploded and burned for 2 days and then sank to the ocean floor. The blow-up prevention device for the Macondo well catastrophically failed, allowing oil to be jetted into the Gulf more than a mile deep. The disaster attracted international media attention for the entire summer of 2010. The Gulf had already suffered from Katrina hurricane in 2005, and it was later to suffer from the extreme flooding in the Mississippi in 2011. How many punches can Mother Nature take in the Gulf? The oil jetting into the Gulf caused droplets of oil to form, with the smallest droplets creating the first ever deepwater plume. Larger droplets floated to the surface and eventually oiled the shore and marshes along the Gulf Coast. 4.9 million barrels of oil were released with the Deepwater Horizon disaster. It was the largest disaster response ever, second largest marine spill in the world. More than 1,000 ships were involved. However, in 1979, a similar spill occurred in the Gulf, releasing 3.1 million barrels of oil, but nobody remembered that. Not all the oil is the same. Here we see the spectra of the Macondo light crude versus Exxon Valdez heavy crude, and the light crude is easier for bacteria to degrade and evaporates faster. Yet the media was immediately comparing the two disasters. We have known that bacteria degrade oil for hundreds of years. Oil is a natural product. Marine algae subjected to high pressures and temperature over millions of years form oil. Many bacteria can directly degrade components in the oil, but it takes a community for the most complete degradation. We wanted to document what was happening during the spill, so we used a systems biology approach going from the ecosystem level to the molecular level and all things in between, because we knew that the whole is greater than the sum of its parts. Thus, we would find new synergistic effects caused by the oil spill. Here we can see during the response phase, with oil coming into the deep from the blowout prevention device in the center, and at the top gas being flared, and then emulsified oil on the surface and sheens, and then in the beaches, and burning of the oil on the surface of the ocean. The microbial community that we found in the deep water sites with oil was distinctly different than sites without oil, and from samples collected in the same area by Dr. Tim Holobaugh at the University of Georgia 1 month before the disaster. The microbial community in the oil was dominated by one group of bacteria, Oceanosporiales. In the left corner, we see a bacterial sample 1 kilometer from the wellhead, where they have already started to divide, as opposed to the other corner showing the fat and happy bacteria 10 kilometers from the wellhead. And of course, it only takes 2 hours to get out 1 kilometer. We demonstrated that the half-life for the oil was 1.2 to 6.1 days by 4 different methods. The well was capped on July 15th after 85 days. From July 27th through August, we sampled in all directions from the wellhead and couldn't find any oil in the deep water. The press was extremely anxious. We analyzed sediment from 1,440 cores at 120 sites. Scientists on board the ships thought that 29% of the oil via sight and smell, those cores were contaminated, yet only 6% were. Media scientists said that the oil must have gone to the ocean floor. Here we see in the Gulf of Mexico, 400,000 to 1 million barrels of oil a year go into the Gulf, and this has been going on for millions of years. This is from natural seeps only. If I was seeking oil degraders, it would be in the Gulf. It was a disaster that will be hard to forget. But similar catastrophes have occurred in the Gulf and other places in the U.S., even though the spill amounts were orders of magnitude lower. Like all politics, all oil spills are local, a combination of factors of oil type, depth, distance to shore, and weather. When our paper came out in Science in August 2010, I gave over 500 interviews and lost count. I still give about 1 a week, almost 4 years later. This Oil Town paper in the Houston Chronicle couldn't resist making fun of our results. And when conspiracy theories abounded, including this example that suggested that BP created a genetically modified bacteria and was injecting that, not dispersant, to the cleanup of the oil spill in the deep. So, in terms of, I think all faculty and graduate students should have some media training. You need to control the release of the media. You need to find your best spokesman. You need to rehearse and review, ask to review the article if they will. You will be when misquoted. Peer-reviewed conclusions only, please. Make sure interviewers understand, repeat, 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 and screen your interviewer. A bad interview can damage your reputation and your institution's reputation. Media attention, however, can have a positive effect by bringing attention to your research, your institution, and your expertise, and increase outreach to the scientific community and the public. So, I'll step back, then step forward, place my hands on the table, and say, actually the opposite is true, a more positive statement. So media training actually helps. We also produced, with a number of different scientists for the American Academy of Microbiology, frequently asked questions for microbes and oil spills. Large group of scientists put this together, including myself and Frank Loeffler, who's here. And we wish we had had this before the spill, because maybe we could have avoided some of the misconceptions and some of the strange media that we saw during the spill. Thank you.